Hi everybody, Patrick here from EngineeringShock.com, EscapeRoomElectronics.com, and PaintballProps.com. In our previous video we actually built this up from scratch. This is a TommyKnocker secret knock unit. It's Arduino compatible. It can control an electromagnetic lock, and it can also control AC devices and DC devices using the onboard relay. And this video is going to be the video manual. So, we've got outputs right here and some input outputs right here that choose the mode selections. We've got our electromagnetic lock enable jumpers. We're going to cover all of this. But if you want to see the assembly video, check out our last video, and also check out the Kickstarter linked below. So, first things first, let's talk about the relay. The relay, this big guy right here, can be used in one of two ways. It can be used to control high power or low power DC or AC devices, or it can be used to control an electromagnetic lock. And we'll get into that a little bit later. But if you want to use an electromagnetic lock, there are two enable jumpers right here, or headers rather. And you need two of these little guys to jump them. Now, if you're going to use the electromagnetic lock, you cannot use AC devices on the same time. If you're going to use AC or DC devices using this 3-pin terminal, you have to make sure that these two headers are not being jumped. Because as soon as you jump those headers, you're adding the power from and the ground line from the rest of the circuitry to the AC line. You'll literally you'll blow up your board. So, in the case of wanting to use the relay specifically for an electromagnetic lock, which we're going to discuss first, you want to make sure there are two jumpers on these two headers. So I'm going to do that. We'll get a closer look, and then we're going to program our board, and then we're going to try using an electromagnetic lock. As you can see, I have jumped them, so now this output right here, labeled mag- and mag+, are now being used by the main power and controlled by the relay. So again, we'll get back to this in just a minute, and we'll talk about how to connect an electromagnetic lock. But first, we're going to program our TommyKnocker. Now, one thing to note before we start is you'll notice that there's a header right here. We don't use We use this header for there are some output lines and then there are some control lines. So in the default state, you'll notice that these two pins are empty, and then there's two jumpers side by side. This configuration is the relay is configured in software, and we have the relay latch on after the first combination a successful combination has been read, and then it toggles states. It turns off if it reads the same combination again. By combination, I mean secret lock. If I have this jumper one more set to the right, two more pins to the right there, what happens is when the unit detects a secret knock, it turns the relay on for about 10 seconds, and nothing can happen during that 10 seconds, and then the relay turns off. So I'll give you a demonstration of that a little bit later, but I'm going to keep that jumper where it is right now. If I want to completely remove the relay function from the software and only use the output pins to drive other circuitry to save power, what I do is I take this jumper and I place it like that, leaving these two pins open. So again, for demonstration purposes, I'm going to place it back in the default state, and I'm going to power it up. Ideally, you want to hot glue or epoxy this piezo sensor to the surface that you're going to be knocking on, or the opposite side of the surface you'll be knocking on. As well, I mentioned this in the assembly video, piezo sensors' worst enemy, aside from physical damage, is humidity. So if you're going to be using this in an area of high humidity, what you want to do is you want to epoxy this or hot glue it to the surface so that it can't be exposed to the elements. Just something to say. But for this video, what I'm going to do is I'm just going to leave it touching the table, because that's all I need to test this. When I plug in the AC-DC adapter, the red LED will turn on, the green LED will blink, and then the red LED will shut off. At that point, we can program in our code. Okay, so let's do a simple one. And now it's programmed. So listen for the relay. So blue means that it detected the correct knock, and so the relay turned on. So that would actually remove power from the electromagnetic lock in our current configuration. We've got those two jumpers there. So now the relay is on, which is disengaged power to the electromagnetic lock. Again, I'll connect that a little bit later. And in order to reset so that the power is on the electromagnetic lock again. I can either remove power or I can... And now the relay is off again, and power is again applied to the electromagnetic lock. I'll give this example again a little bit later, but now what I'm going to do is I'm going to start over with a different configuration. What I'm going to do is I'm going to I just created a knock there, and obviously it didn't accept it because the red LED flashed. What I'm going to do is I'm going to stop the video, and I'm going to change the setting of the jumpers so that the relay is not on at all. As you can see, I've changed the jumper, the left jumper, one pin to the left. Power, program into no code, and let's try it again. Now you think, okay, the relay is no longer in function because it's programmed out of the software. So what is the board doing then? Now that comes a little bit later, because what we're going to do is we're going to hook up some LEDs to these output lines, and basically these outputs allow for you to interface your TommyKnocker with your own circuits, your own TTL compatible circuits, like your Arduino Uno, for instance. So now what I'm going to do is I'm going to place the jumper again back to the default state, and I'm going to change the right jumper to the right slot so that we can see the momentary relay trip. So the left jumper is in its default position, 2 in from the right, or from the left rather. These 2 pins are empty. The middle pin is not being jumped, but then these 2 pins are being jumped, and that means that the relay is activated, and it's going to be activated only in momentary mode. So that what's going to happen is when I enter in a correct knock, the relay is going to turn on for about 10 seconds and then turn off. And we're going to give that a try. We're going to listen for the relay. Now, listen. Once I program in the knock, I'm just going to program in the same knock for simplicity's sake. Once I program that in, listen for the relay, and then after about 10 seconds, you'll hear it click off again. So, okay, it's programmed. Okay, it's turned on. Nothing happens during this time. You can still knock, but nothing's going to happen. Now listen for the relay click. There it is. And the blue LED flash is saying, okay, we're ready for a knock again. And so we can do the same thing over and over again. But in this state, the relay turns on for 10 seconds, then turns off. Whereas the default state, every time you enter in a correct knock, the relay toggles states from off to on, and then on to off. Okay, so what I've done here requires a little bit of explanation. What I've done is I've connected the ground line, labeled GD, the rightmost pin right here, to the ground, to the negative rail on my breadboard here. I've got 5 470 ohm resistors, each to the negative or cathode of every LED here. I've got 2 green LEDs which react differently based on when you get a positive, when the unit detects your secret knock, a real secret knock, and I've got 3 outputs in red that react differently if the unit receives an incorrect knock. So let me just talk about where these are connected. I've got black right here. I've got gray to the rightmost green LED, and that's connected to the 0 pin right here. It's labeled 0. And the white wire is connected to 1 on the main board. Now, we've got from the right and to the left, red, orange, and yellow. Excuse me. And from this perspective, we use the leftmost pins from the 10-pin header. And on the bottom of the board, you can actually see the numbers on the bottom of the board. There was no room to place them on the top. But on the bottom, red is connected to the 5-pin. It's labeled 5. Orange is connected to 6. And yellow is connected to 7. So just look at the bottom of the board and use this video as basically as a manual. That's what it is. So when let's power this up, and we'll talk about these signal output. So I've programmed a very simple knock, three quick knocks. And the relay is still on. We're not going to listen for the relay clicks, but as you can see, the gray wire is connected to pin 0 on the 6-pin header, and white is connected to pin 1 on the 6-pin header, which is the latching output. So as you can see, every time it receives a correct knock, this LED will toggle, this LED will turn on for a short period of time, then turn off. Okay, so now it's, sorry, I wasn't ready there, because the blue LED flashed, you couldn't see it on the camera. One more time. So that's a very simple knock. And you want to make sure you get your timing down, because if you don't have your timing right, it's not going to recognize it. Now, the red wire is connected to the to this LED right here, which is also connected to pin 5 on the 10-pin header. And that is one of your 2 latching outputs. Pin 6 on the 10-pin header is connected to the orange wire, which will always be the opposite logic of pin 5 on the 10-pin header. So these will always change logic every time the unit receives an incorrect knock. The yellow wire is connected to pin 7 on the 10-pin header, and that's our momentary output, which means every time an incorrect knock has been received, it will turn on for a short period of time, then turn off again. So let's just try a few knocks here, a few bad knocks. So as you can see, these 2 LEDs are always opposite from one another, and they latch on and off, whereas this LED only turns on for a short period of time. So let's try our green LEDs again, see if we can get the same timing. So there you have it. This is how you interface with your Arduino Uno. You can have, what I would do is typically I would hook up my momentary output here, connected to pin 4 on the, or pin 7, sorry, on the 10-pin header, and I would connect the momentary output from, excuse me, the 6-pin header, pin 0, for a positive. So I can say, so I could write a code with my Arduino Uno saying, if there's a bad knock, do this. If there's a good knock, do this. So that's how that works. It's very, very simple. If you have any questions, you can message us directly through engineeringshock.com, engineeringshock@hotmail.com, or through our websites, or through Kickstarter. Again, the Kickstarter is linked below. So now let's talk more about the electromagnetic lock, and we'll end this video off with controlling an AC device with the relay. So I've got my control jumpers in the default places, which means that every time a secret knock has been received, it will toggle states of the electromagnetic lock. On power up, the electromagnetic lock is engaged, it is powered. When the relay turns on, it removes power from the electromagnetic lock. Now what I've got here is the electromagnetic lock connected to mag plus, and I've got the negative wire, the black wire of the electromagnetic lock, connected to mag minus. I've also made sure that I've got my 2 jumpers connected. Now remember, only have those 2 jumpers connected when you're using the electromagnetic lock. If you're ever going to use this relay as a high-powered switch for AC or DC devices, you have to remove those 2 jumpers, or else you'll blow up your circuit, and nobody wants that. So let's do a demonstration. I should mention that if you pledge towards a kit that includes an electromagnetic lock in the Kickstarter, it comes with a mounting bracket and some mounting hardware, and I will supply the video that I have on this mounting hardware and how this all goes together. That aside, let's do a demonstration. Let's power up. And the electromagnetic lock solidly in place. So let's program in a knock. Again, I detected that as a bad knock. Pops off, and it will stay off until I give it another tap. And now it's engaged again. So that's very simple. What if we change our jumpers so that it's only off for a short period of time? I'll change this to this. Sorry, I should have removed power before showing you that. But now when I turn the relay on, or when the unit receives a correct code, what will happen is the relay will turn on for about 10 seconds and then turn off. So It's off. And we'll just wait for the relay to click off. And then the electromagnetic lock will re-engage. There you go. Back on. So, again, if I set the jumper selection in the beginning on power up, as I mentioned before, you can completely remove the relay function from the software. So, now that you know how to use an electromagnetic lock, why don't we talk about AC devices? For this demonstration, I've removed the electromagnetic lock, and more importantly, I've removed the two enable jumpers. Now, I can safely use this output, which is connected to the relay. Now again, the relay is a high-powered switch that's controlled via the main circuitry, but it's isolated from it as well. And there are three isolated pins here. NC, which is normally closed, CO, sorry this is backwards, common, and NO, normally open. By default, when the relay is off, the common pin is connected internally to the NC pin. So right now, essentially these two pins are connected internally. And this is how this is a switch. When the relay turns on, the common pin disconnects from the NC pin and connects internally to the NO pin. So if I sever the hot wire of an extension cord and I place one side in the common pin and the other side in the normally open pin, when the relay turns on, it reconnects those two severed wires. Whereas if I had the hot wire severed and one wire connected to the common pin and the other to the normally closed pin, the NC pin, when I powered the unit on and the relay was off, power would be already flowing. The circuit would already be connected. And when the relay turned on, it would sever that connection because the common pin would be connected to the normally open pin. So what I'm going to do is I'm going to get a lamp, I'm going to make one of these connections, and I'm going to give you a demonstration. So what I've done is I've taken an extension cord, a two-prong extension cord, and I've severed the hot line. Now you don't have to use the hot line, you can use the neutral line, but electrical code says that you're supposed to use the hot line. I'm using the hot line. I would suggest you do the same. So what I need to do is, initially these are connected, and I've severed it. So I've stripped away the insulation, and I'm going to connect one wire, doesn't matter which one, to the common pin, and the other to the NO pin, the normally open pin. So when the relay is off, by default, no power will be flowing through these wires. When the relay turns on, that connection will be made through the relay. So I'm going to make those connections, and I'll stop the video. I'll start it again once the connections are made to give you a look, and then I'm going to connect this side to 120 volts AC mains. Again, you don't want to go anywhere near that terminal block when you're doing this. And I'll connect the other side to my lamp, which will be in the on position. As you can see, I've connected to CO and NO, and I've left NC unconnected. If I wanted for power to remain on when the relay is off, by default when you power up the TommyKnocker, I would switch this wire to here, to the NC, so the power would flow common through normally closed. Now again, there's no power on right now, I haven't connected to the wall, but if there were, I wouldn't want to go anywhere near these lines because you'll get a hell of a shock. It's very dangerous. So only use AC devices if you're comfortable with it, if you know what you're doing. This video just serves to give you a quick example of how to do it. So now what I'm going to do is I'm going to connect my lamp here. I'm going to make sure that my lamp is on, and I'm going to connect this side to mains. I've got my AC adapter plugged in, connected to the TommyKnocker. I've got my lamp connected to the modified extension cord, and I've got that modified extension cord plugged in to this power rail. So now what I have to do is turn it on, program in a code. It's programmed. Lamp turns on. Oh, I've got this on momentary mode. So if I had this on latching mode, it would have stayed on until it received another knock. So an incorrect knock, nothing happens. And a lamp turns on for another 10 seconds, then turns off. So again, if you have this configured for momentary, for latching mode, for the relay latching mode, this lamp will stay on until you enter in the same knock again. So that's the user manual. I hope you found it interesting. I know it's a very long video. I hope that it's been useful to you. If you haven't already checked out the Kickstarter campaign, check it out. Now it's linked below. Thanks so much for watching, everyone.